Hello everyone, today our group will present about motion in space, especially velocity and acceleration. We will learn the concept and look at some examples, so let's get started. Okay, for the introduction, motion in space describes how an object moves through three-dimensional space over time. In this topic, we focus on two important concepts, velocity and acceleration. Velocity explains the speed and direction of motion, while acceleration describes how the velocity changes with time. These concepts are widely used in physics, engineering, and space science to analyze the movement of particles and objects.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Okay, today we are going to learn about the topic motion in space, velocity and acceleration. Here's the first question, which is the low level questions. Okay, now we read the questions. The position vector of particle moving in 3D space is given by the vector valued function. Okay, this is the vector function, which is t the power of 3 plus 2t in bracket I plus if exponent the power of 2t j plus sin 3t k. Okay, the question is determine the velocity vector and the acceleration vector of the particle at any time. Okay, to search the velocity, the first one is we need to differentiate the first function first, which is this one. All of the function or the bracket we need to differentiate. Okay, the first one is we differentiate t power of 3 plus 2t and then plus differentiate exponent the power of 2t plus differentiate sin 3t plus k. And then after we differentiate, we got the answer, which is 3t the power of 2 plus 2i plus 2 exponent the power of 2t j plus 3 cos 3t k. Let us settle the first one, which is we know the velocity of the vector is this one. And then we got the second questions, which is we need to search the acceleration vector. When we need to search the acceleration vector, we need to differentiate the velocity one. Okay, not the first one, this one. And then we differentiate as usual, which is we differentiate 3t plus 2 and then we differentiate 2 exponent the power of 2t and differentiate 3 cos 3t. And then we differentiate and then we got the final answer, which is 6ti plus 4 exponent the power of 2tj minus 9 sin 3t k. Okay, that's all.
Okay, next we go for the next question, which is medium level question. And the question is an object move in space with an acceleration vector given by at equals 60i plus 4j plus exponent to the power of minus t k. So the object starts at the origin with an initial velocity vector, which is v0 equal I minus 2j plus 3k. Derive the complete expression for the velocity vector, which is vt at any time. Okay, so to find the velocity vector, we need to integrate the acceleration vector. So we need to integrate the equation, which is this. So we need to integrate and we got this equation, which is 3t squared I plus 4tj plus negative exponential to the power of negative t k plus c. Okay, so the question gives us velocity vector v0 is equal to I minus 2j plus 3k. That we need to substitute this v0 into this equation. So we got this answer, negative k plus c. Then we know that v0 is this, so we need to compare, and that we get c is equal to I minus 2j plus 4k. So when we get this c, we need to combine with the answer that we integrate the acceleration vector. So we get the final answer is 3t square plus 1 I plus 4t minus 2j plus negative exponential to the power negative t plus 4k. Okay, next we go for the next question, which is question 3, the same level, which is medium level. So the question is, a space drawn travels with an acceleration vector described as at equal to 60i minus 12 sine 2tj plus exponent to the power of negative t k. So the drone is initially observed at a space coordinate r0 equal to 2i plus 3j plus 5k with an initial baseline velocity of v0 equal to 4j minus k. Determine the exact position vector equation rt of the drone at any time t. Okay, so first of all, we need to find the vt. So we need to integrate this equation. So we get this answer, which is 3t square I plus 6 cos 2t j minus exponent to the power of tk plus c. So the question give the initial baseline velocity, which is this. So we need to substitute 0 to the equation this. So we get this answer. So we need to find the value of c, which is we get negative 2j. So for the second, so we need to combine this value c equal to negative 2j and this equation to get a new equation, and we need to do this because we need to find the RT. So to find RT, we need to integrate one more time, and we get this answer, t to the power of 3 I plus 3 sine 2t minus 2t j plus exponent negative tk plus d. Why we use d? Because for the first integration we use c, so we need to change into d, and we need to do the same step, which is we need to substitute 0. So we get the value of d, which is 2i plus 3j plus 4k. So the final answer is this, RT equal to t to the power of 3 plus 2 I plus 3 sine 2t minus 2t plus 3j plus exponential to the power of negative t plus 4k.
Okay, next we go for the question 4, which is height level questions. Okay, first we read the question first. Okay, a space probe of constant mass m equal to 2 kg experienced as a net external time dependent force vector defined by Ft equals to 12 cos Ti minus 24 T the power of 2 J plus 8 exponent the power of 2 Tk. And then the question tells us that at T equal to 0, the particle's speed is evaluated to be exactly 0, speed equal to 0. Knowing that the position vector at t equal to 0 is r0 equal to I plus 2k. Then find the explicit coordinate of the position vector of rt at any time. Then prove analytically whether the acceleration vector and the position vector are orthogonal to each other at the specific moment t equal to 0. Okay, the question asks us, the first one is, the question wants to find the coordinate of the position rt. And then the second question is, prove analytically whether the acceleration vector and the position vector are orthogonal to each other at a specific moment t equal to 0. So, to find the r equal to t, the question gives us only ft. Okay, the question did not give us acceleration or velocity. So, okay, by applying the Newton's second law, we know that F equals to ma. So, when we have the F and also the m, so we could search the acceleration. So, the first step is we search the acceleration first using this one, and then we got acceleration equal to 6 cos t I minus 12 t square j plus 4 exponent the power of 2 t k. And then when we have the acceleration, we need to search the velocity by integrating the acceleration. So we integrate the acceleration, we got the velocity t, and then we integrate, and then we got the c. And then the questions tell us that the speed is elevated at exactly 0. So this one is equal to 0. Why? We need to equal to 0 because we want to search the constant c. And then after we search the c, we got c equal to negative 2k. And then we substitute c into the equation. We got 6 sin t I minus 4t the power of 3j plus 2 e exponent the power of 2t minus 2k. And then we got the velocity, and then we need to search for r in the bracket of t. So we integrate the second time, we got the constant d. So how to search the constant d? The question tells us that the position vector at t equal to 0 is this one. So we substitute this one into this equation to find the d, the constant d. So the last one is we got the position vector r bracket of t equal to 7 minus 6 cos t I minus t the power of 4j plus exponent the power of 2t minus 2t plus 1k. And then we settle the first question, which is the question want the explicit coordinate of the position vector. Okay, the second question we need to prove the analytically whether the acceleration vector. We need to use the test orthogonality, which is we use the dot product. And then we only have r0 because the question mentioned here. We don't have the acceleration 0. So we need to substitute 0 into the acceleration first. And then we substitute, we got the 6i plus 4k. And then we also got this one is given from the questions. And then we substitute, we use the dot product, this one, and then we got the 14. Okay, we can conclude that since acceleration at the specific moment t0 dot the position vector at the specific moment t0 is not equal to 0. So the vector are analytically not orthogonal at t equal to 0. So that's all. Thank you.